Section 7.3, double angle, half angle, and reduction formulas. As usual, as we work through this section, make sure you have the unit circle handy. So these are double angle formulas. They read sine of 2 theta is equal to 2 sine theta cosine theta. Cosine of 2 theta equals cosine squared theta minus sine squared theta, which is the same as 1 minus 2 sine squared theta and 2 cosine squared theta minus 1. Tangent 2 theta equals 2 tangent theta divided by 1 minus tangent squared theta. Now notice, what's being squared, if I have a value that's twice as much, I can get theta by itself with these formulas. Notice that we have these values for sine and cosine without that 2 theta, having theta by itself only. This will be helpful when we're trying to evaluate a value where half as much is found in the unit circle, but twice as much isn't. And we'll see some examples as we move forward. It's also going to be very helpful in the next section. So we skip 7.4 and 7.5 when we have equations. Super helpful there. Because sometimes we can evaluate for 2 theta, but we can evaluate by theta by itself. So that's something to keep in mind. So this first equation, or example, reads, given that tangent theta equals negative 3 over 4 and theta is in quadrant 2, find sine 2 theta. So just like before, we can use our equations to find unknowns. Now what we need to find is 2 theta. Now the formula for sine 2 theta is 2 sine theta times cosine theta. So what we need is a value for sine theta and a value for cosine theta. I'm given tangent. That's not much help, but we can develop our ideas to fit to what we need. All right, so I'm going to split our page to what we want to find and what we need to find it. So we're being asked to find sine of 2 theta. So we need the value of sine theta and cosine theta. I'm only given tangent. Let's go ahead and draw this out. We're told that we're in quadrant 2. So if I draw this out, if I'm in quadrant 2, I draw my reference triangle. Tangent is made up of opposite over adjacent. So I'm going to ignore the sign for a moment, and opposite of theta is 3. Next to it, that's not the hypotenuse, is 4. Now, the negative tells me that one of these is negative, but it's in the middle, so I have to be careful to see which one it is. We see that my y's are positive, because I have positive 1, positive 2, positive 3, and so forth. My x's are negative, because then I would have negative 1, negative 2, negative 3, negative 4. So the negative belongs to the 4. That's tangent. Now, in order to find sine and cosine, I need to find this unknown, this hypotenuse. So to find that, I use my Pythagorean theorem. A squared plus b squared equals c squared. My c squared is the unknown. C squared is always your hypotenuse. So I have 3 squared plus negative 4 squared. 9 plus 16 equals c squared. 9 plus 16 is 25. Take the square root. So you have plus or minus the square root of 25 equals c. Now, do we want plus or do we want minus? The hypotenuse is always positive, so I want positive. The square root of 25 is 5. So my value that I need to find was 5. Now I can find the sine value and the cosine value. Let's figure them out. So sine is made up of opposite over hypotenuse. Opposite of theta is 3. The hypotenuse is 5. So I have 3 over 5. Cosine theta. Cosine is adjacent over hypotenuse. The the value that's adjacent next to it would be -4, and the hypotenuse is 5. So I now have found the value of cosine and the value of sine. So that we have 2 is sine theta. My sine is 3/5. And my cosine is -4/5. All right, so that we just multiply across. So I can think of this as 2/1. 2 times 3 times 4, that gives us -24. 1 times 5 times 5, 25. So this is the value of sine 2 theta. We also have half angle formulas. They read sine of alpha over 2 is the same as plus or minus the square root of 1 plus cosine alpha over 2. Cosine alpha over 2 is equal to plus or minus the square root of 1 plus cosine alpha all divided by 2. And tangent has 2 of them. Tangent alpha over 2 is plus or minus the square root of 1 minus the cosine alpha divided by 1 plus cosine alpha. Sine alpha plus 1 plus cosine alpha. And 1 minus cosine alpha divided by sine alpha. There's 3 of them. I said 2, but there's 3. Okay, so let's see how we can use the half angle formula, and you can use your double angle similarly as well. So let's find the sine of 15. And if you take a look at your unit circle, we don't have 15 degrees. We have increments of 30 and 45. So how can I find this using my double angle formulas? All right, so let's take a look at our formulas above. And we see that we have sine alpha over 2 is equal to plus or minus the square root of 1 minus cosine alpha divided by 2. All right, so to evaluate this, think of 15 as 30 divided by 2. Because we know the value of 30, and if I divide it by 2, it gives me that increment that I want, that 15. So I'll now think of this as sine as 30 over 2, where 30 would be your alpha. And then from there, we just use the formula. So our sine rule that we have right above tells us that we have the square root of 1 minus cosine alpha. Our alpha is 30 divided by 2. All right, so the square root of 1 minus, what is cosine of 30 looking at unit circle? That's the value square root of 3 over 2, all of which is divided by 2. All right, from there, we just have to simplify your square root. And honestly, the trigonometry isn't so bad. The algebra is what takes time. So I have 1. Well, let's first take our numerator and get a common denominator. So I need to multiply this by 2 over 2. So that I have 2 over 2 minus square root of 3 over 2 divided by 2. So I have 2 minus square root of 3, and they both have denominator of 2. All of that's divided by 2. Okay, let's ignore the radical for a moment and focus only what's on the inside. I know that's division, so let's rewrite it. So I have 2 minus square root of 3 over 2 divided by 2. That's the same as 2 minus square root of 3 over 2 times 1/2. So that's 2 minus square root of 3 over 2 over 4. So that we have the square root of 2 minus the square root of 3 over 4. And I can split my radical, the square root of 4 at the bottom, and I have 2 minus the square root of 3. The square root of 4 is 2. So I have the square root of 2 minus square root of 3 over 2. That's our final answer. And as you see, we were done with the trigonometry portion in 2 steps. The algebra was all that time it took to do it. All right, you also have reduction formulas. These are helpful, or they're good to see and to be aware of them because it helps us take us from a squared value to a value that's not squared. And you can use this however you see fit. In the future, this is nice to know. For example, maybe in calculus where you're trying to integrate. All right, that's it for this section, 7.3, double angle, half angle, and reduction formulas. Thanks.